Alright, so we're recording. Okay, so this is just an example of solving a trig equation. So we're trying to solve for x. We're trying to solve the bounds for x. We'll just make them 0 to 2 pi. Okay, but our function that we're going to solve, I'm going to say, let's do 2 sine 2x is equal to negative root 3. So this one here is a little bit different to the ones we've been doing, but I don't think it's too much more complicated. Let's get that on frame. Alright, so the first thing we need to make sure we're doing, we want the periodic function on its own. Okay, so how do we do that? Anyone?
Divide by 2 on both sides.
Thank you, Mary. Divide by 2 on both sides. So we have sine 2x is equal to negative root 3 on 2. Alright, so I've got this is the actual thing this is the hard part of the trig equation. So I'm trying to find out what x can be to fit into this. Like any equation, I want to know what the x is that fits, that balances the equation. So what am I doing first? Base angle. So I need to find the base angle. So I'm going to let theta. So I'm going to let sine theta equal negative root 3 on 2. So whatever's within my periodic function, I'm going to replace that with just a nominal theta. Okay, if my equation already had theta in it, I might want to change it to alpha or something like that. But let's just say we've got 2x there. I'm going to swap that with theta. So now, can I find theta? Oh, and what's the other? I've done this a little bit wrong. With my base angle, I want the positive value. So the sine of theta is the positive value because I know that theta is going to be a value between 0 and pi on 2. So it's a right angle. So this one is an exact value. So what do I use to solve for theta? Special triangle. And it's going to be my 60-40 one. 60-40. 60-30. So that's 1, 2, root 3. Sine, it's the opposite over hypotenuse, so it's this angle down here. Pi on 3. So I know that sine of pi on 3 is equal to root 3 on 2. So therefore theta must be equal to pi on 3. So I've got my base angle here. Okay. So I'm nearly ready to solve this, but I just need to make sure that I get the right number of values. So I need to be solving this within the right bounds. So my bounds for x are 0 and 2 pi, but I'm actually solving this for theta, well, kind of, for 2x, okay? So what I need to do, thank you, I'm going to double this in equation. So I've got 0 to 2x to 4 pi. So 4 pi. So this is an equation just like any other equation. I double the middle, I double the bound. So 2 times 0 is 0, 2 times 2 pi is 4 pi. Don't laugh. You'll appreciate this when you're panicking before the exam and you don't know how to solve these. You can look up this video online and it'll make everything really clear. Alright. So, where were we? Okay, so I know my bounds for solving this are between 0 and 4 pi. So the next thing I'm going to be doing is what?
Determine positive or negative in which quadrant?
Well, yeah, determine the quadrant. So I know I've got a negative value here. So I'm looking for when my sine function is negative. So it means that my sine function is going to be negative in the c and the t. That's a t. Definitely a t, in these two quadrants. So I'm looking at angles where I have a theta sitting here and a theta sitting here. That is a theta. So what I'm going to do, I'm going to start at 0. So 0 starts here. I'm going to go around until I find one. I'm going to label what the angle is first. So 0 to here, this is pi. So pi plus theta is my first one. Pi plus theta. If I keep going around to this one, this is 2 pi. So this angle is 2 pi minus theta. Now I'm only up to 2 pi. My bounds are to 4 pi for 2x. So I'm going to go around again, and I have, this is pi, this is also 3 pi. So 3 pi plus theta. And if I keep going around to 4 pi, this is 4 pi take theta. So I have 1, 2, 3, 4 possible solutions. So that means I have four equations to set up. So I have sine of pi plus theta is equal to negative root 3 on 2. I have sine of 2 pi take theta, still in frame, is negative root 3 on 2. Sine of 3 pi plus theta is negative root 3 on 2. And sine of 4 pi take theta. Now keep in mind I do have a value for theta, which is that. I'm just writing theta because it's quicker to write than pi on 3, pi on 3, pi on 3. It's just repetitive. Anyway. But I do know that I have, in my original function I had sine of 2x is equal to negative root 3 on 2. And I've set up these 4 equations where it's sine of something equals negative root 3 on 2. So what does that mean? That's right. 2x could be any of these values here. I'm assuming that the person watching this has just answered that question because no one here did. Okay, so what's in these sine functions down here are all values for 2x. So now I have 4 equations that I can set up. So I'll do them down here. So my first one, I have 2x, and I'm going to replace the theta with the pi on 3. Keep that in mind. Don't get. So we've got pi plus pi on 3, which is 4 pi on 3. So that means that x, if I halve that, it means I double the denominator. So I have 4 pi on 6, which is really 2 pi on 3. My second one, 2x is equal to 2 pi take pi on 3, which is 5 pi on 3. So x is 5 pi on 6. I'll do my others down here. Well, let's go on a frame. So we've got number 3 down here. 2x is equal to 3 pi plus pi on 3, which is 9, 10 pi on 3. So x is going to be 10 pi on 6, which is 5 pi on 3. And my last one, I'm all over the place here. 2x is equal to 4 pi take pi on 3, which is 11 pi on 3. So x is going to be 11 pi on 6. So I have 1, 2, 3, 4 values for x. And you might want to note they should be between 0 and 2 pi. And the biggest one, which is this one, is less than 2 pi. So they will fit in that range. Yeah. And that's that.